Hello, this is section 3.1 measures of the central tendency. We want to kind of review that what was a statistic and what was a parameter. So statistic is a characteristic of the measures obtained by using the data values of from, this is typo errors here, should be the from a sample. Okay, and then parameter is a characteristic or measure obtained by using all the data values from a specific population. So general rule for rounding rule. So in statistics, the basic rounding rule is that what computations are done in calculations. So rounding should not be done until the final answer calculated. So rounding should not be done until the final answer is calculated. When the rounding is done in the intermediate steps, it tends to increase the difference between the answer that you might have and the answer that what we want. Okay, so all right. So the first the measures of central tendency is the mean. So mean is the sum of the value and then divided by the total number of the value, which is sample mean. We call the x bar. So x bar is going to be adding all the data value and divide by number of the data, which is we use a sigma, which is adding all the x values divided by n. So n is the represent the total number of the values. So population mean we call the mu, and then mu is the same thing. So you're adding all the data values and divide by the total number of the value, the total number of the values. Okay. So rounding rule for the mean. The mean should be rounded to one or more decimal places than the occur in the raw data. So for example, if the raw data has a whole number, and then the mean should be rounded up to the nearest tenth. And then if the data are given in tenth, and then the mean should be the nearest hundreds. Okay, so you always go to one more decimal place. All right, let's get the mean. Okay, so the number of the confirmed flu cases for 9 years period is shown. Find the mean. So let's say this is the x bar, which means you're adding all the numbers 98, 115, 88, 44, 73, 48, 62, and divide by 9. And then you get the sum of 578 over 9, which becomes 64.2, but this is a rounding number. Okay, so since the data values are the whole numbers, we round up to the first decimal place. Find the mean for the group data. So group data. So now you have a lot of data. So before we adding all the data value as a 10 or 100 or 1,000, right? We might want to make the classes first. Okay, so make classes and then find the frequency, and then which means that the best number you use for the represent that the classes is a midpoint. Okay, so you find the midpoint and then multiply the frequency. The midpoint will be the total value of that class. Number 2 step, find the midpoint of the each class, and then multiply the frequency by the midpoint in the column D, and then we need to find the sum of the D column, and then divide the sum obtained in column D by the sum of the frequency obtained in column B. And then we are just using this formula to find it. Okay, so let's do the example 2. So the frequency distribution shows the salaries in millions for a specific year of the top 25 CEOs in United States. Find the mean. So the midpoint, in order to find it, right, you can use the class limit or class boundaries. But since we have a class boundary to use, okay, so first class, okay, use adding the 15.5 to 20.5 and then divide by 2. So what you do is each class for the midpoint, you have to use a lower boundary plus upper boundary, add it up and divide by 2. So which means the midpoint for this one is 15.5 plus 20.5 and divided by 2, which is, I guess, the 13. Oh, no, I get 18, sorry. I get 18. All right, and then same thing. So you are adding from the 20.5 plus 25.5, and then your midpoint will be the 23. And then for the class width, which is, you can get it from the 20.5 subtract the 15.5, or 23 minus 18, and then it becomes a 5. So you just keep adding the 5. So you gotta get 28 and 33 and 38. And then you multiply the frequency. You're going to multiply by frequency to the midpoint to get the product of the last column. So multiply 13 times 18, it becomes 234. 6 times 23 become 138. And 4 times 28 equals 112. And then the 1 times 33, 33, 1 times 38, 38, okay? Now, we need to get a sum of these values, okay? So sum of f times midpoints are, add it all together, you got 555. And then use a formula which is x bar, which is sigma f times x sub n over n. And then this is a 555. And then if you're adding all the frequencies, the sum becomes 25. And then you got approximately 22.2 millions. Okay, so that's a mean for the problem of the group data. All right, let's talk about median. Median is another the measure of the central tendency. So median is the midpoint of the data array. So the symbol we use as MD as for median. And then find the median is we need to use the data value in the ascending order, so which means the least to greatest. And then determine the number of the value in the data set. So you have to see how many numbers. So if there are odd numbers, and then select the middle data value. The middle number will be the median. But numbers are even, you get the two middle numbers. So what do you do? Add them up and then divide by 2. Alright, so we have to decide it. So first of all, we need to make sure that number is in the ascending order. So you need to see what's the smallest number. I see 17.6. And next one is 69.8. 108.2. And 159.8. And 222.6. So there are 1, 2, 3, 4, 5. So what's the middle number? The numbers are 108.2. So that's the median. And also easy to find it is, since there's a 5 numbers, okay, and then always divide by 2, you got the decimals, okay. And then in order to find it, you have to use the next whole number, which is, so third place give us the median. Okay, next example. The number of the tornadoes that have occurred in United States over the 8-year period follows. Find the median. So yeah, we have to also need to find the number in the ascending order. So I need to put down the ascending order first. So I think the 656 is the lowest. 684 and 764. Oh no, sorry, I have to switch it, right? 702. I see 702. So 702 and 764 and 856 and 1132, 1133, and then 1303. Okay. All right. So now is the numbers. How many numbers? So we got 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there are 8 numbers. So a number means there are 2 middle points. Okay. So what I do is I use a 8 and divide by 2 makes a 4. Okay, so because of even numbers, you need to find the first place and the fifth place number. So first, second, third, fourth, and fifth, which is you have to use this number to this number, which means add them up and divide by 2. So when you do that, you get 1620 and divide by 2, it's going to be the 810. So that's a median for this number. So even though 810 is not the available number, and that's the number we can call the median, okay? And then as the third one is a mode. So I'm going to talk about the mode, okay? So the mode, the value that occur most often in the data set. So count is called the mode. So unimodal, which is a data set has only one value that occurs the greatest frequency. Bimodal means two values occurs in the frequency. So sometimes you might have two modes. Multimodal, which means the data set more than two values occur to the greatest frequency. So you might have 3 or 4 mode too. All right, example 5. The data shows the number of the public libraries in a sample of the 8 states. Find the mode. So you have to see what number occurs the most, okay? So 114, I think I only see one. But I see the 27 here to here. And 21 happens once. And 101 happens once. 311, 115, yeah, everything happens once. Only the 77. So this is a mode. The data, next example, the data shows the number of the licensed nuclear reactors in United States for the recent 15-year period. Find the mode. Okay, so there are, these numbers has been not in order, but so let's see, there's a 104, but there's a 1, 2, 3, 4, 5. So 104, there's a 5 numbers. 107 only one, but there's a 109 has 1, 2, 3, 4, 5, 6. Oh, there's a 6. And then 110 there's only one. 111 has 2, but 112 has 1, right? So one number occurs the most, 109. So what is 109? All right, the data shows the number of the patients secured for the top 5 companies for the specific year. Find the mode. And so when you check the 6,180, I don't see the number. That's a once, happens once. So there's no number happens more than once, which means this is a case of the no mode. So sometimes you have a no mode case too. Now, modal class. The mode for the group data is a modal class. The modal class is a class with the largest frequency. So the mode is only measures of the central tendency can be used in finding a most typical case when the data are the monomial or categorical. So example A, find the modal class for the frequency distribution for the salary of the top CEOs in the United States. So which one has the most frequency is 13, right? That means this is, we call the modal class. Okay. In the example 9, the data shows the number of the gallon of the various non-alcoholic drinks Americans consume in a year. Find the mode. So which is the most gallons? 52, right? That means a soft drink is a mode. So this is a categorical, the data, right? And the outlier, extremely high or extremely low, okay? So if you compare with the other data values, and then one or two is a very high, very low, and then can have a striking effect on the mean of the data set. So these extreme values we call the outlier. So example 10, a small company consists of the owner, the manager, salesperson, and 2 technicians, all whose annual sales are listed here. So when you take a look, do you see the outlier? Because owner salary is 100,000, manager 40,000, salesperson has 24,000, technician has 18,000, another technician has 18,000, right? So yeah, 100,000 is a lot more than the other people, right? So outlier should be the 100,000. Okay. All right, but there's a way that we can find the outlier when we need it, okay? All right, let's find the mean. So mean for this problem is, okay, so this is one company, so mean I can call it as a mu. So what you do is adding all the 100,000, 40,000, 24,000, and then there's a 2 of 18,000, right? And then divide by 5, right? And then you get about the 40,000. So that's a mean or a median. And then which is MD, right? So median is, the number is already ascending order if you take a look at this way, okay? So there are 5 numbers. So 5 divided by 2 is a 2.5. So third place is going to be the median. So first, second, third. So it has to be the 24,000. And then mode, what number occurs more than once, which is 18,000. Okay, so as you notice that mean and median mode come out the different values. But the what values you think you should use to see that what's the average of the salary for that company? In my opinion, I think it's a median, because 24,000 kind of number, because that's kind of middle number from the owner is already outlier. So I want to say, because 18,000 is too low, 40,000 too high. So I think it's 24,000 sounds right. Mid-range. Okay, we talked about the range before. So range is that find out the highest value and then find the lowest value and then subtract highest value from the to the lowest value, and then that becomes a range. But this time is a mid-range, is we are adding the lowest value to the highest value and divide by 2, and that we call the range. Okay, so number of the bank failure of the recent 5-year period is shown. Find the mid-range. So in order to find the mid-range, we have to find the lowest value, which is I see 3, and the highest value I see as 157, and divide by 2, which is 160 over 2, which is 80. So this is a mid-range. So mid-range is another forms to find the measure of the central tendency. So in order to find the central tendency, we have the mean and the median, mode, and the mid-range. Okay, so there are 4 different ways you can find it, but we don't use mid-range there often though. Weighted mean. Find the weighted mean of the variable x by multiplying each value by the corresponding the weight and divide the sum of the products by the sum of the weight. So this is the formula for the finding the weighted mean. Okay. So this is the weight. This w are the weights, and then the x are the values. Okay. So example 12. So when we using this kind of stuff, when we find out the GPA, a student received A in English Competition 1, which will give him 3 credit, and then C for the introduction to the psychology, which is 3 credit, and then B in biology 1, 4 credit, and D in physical education, 2 credits. Assume that A is 4 grade points, and the B is 3 grade points, and C is 2 grade points, and D is 1 grade point, and the F is 0. So find the students' grade point, the average. Okay, so let's fill in first. So credit for the English was 3 credit, and then for the psychology also 3 credit, and biology of 4. And then the physical education is 2. So this student took the 12 unit class. And then the grades for the English was A, which gave him 4 points. And then the psychology is C, which gave him 2. And the biology is a B, which gave him 4. Oh, no, give him 3. What am I saying? And then the P got D, which gave him 1. Okay. All right. So we need to find the GPA. So what I do first, okay, we need to multiply the weighted to the value each other, okay, which is 3 times 2, 4 times 3, and then 2 times 1, and then divide by weights of the sum of the weight. And then when you do that, you get the 32 over 12, approximately 2.7, which is giving him a C. So even though he got an A and B, but he got the grades as 2.7 as a C, right? As overall. All right, so shape of the distribution. So in chapter 2, many different shapes of the distribution were discussed. And the 3 most important shapes to consider are those the positive skewed, positive skewed and symmetric, and the negative skewed. So first one is this is actually the right skewed, right? Right skewed, because the right sides are flat, right? When you have a right skewed, and then we call this is a positive skewed, so these are the same name. But which means if you have a positive skewed or a right skewed, always a mode comes the first and the median and the mean ways, okay? For the negative skewed, which is the left skewed, okay, this is what we call the left or the negative skewed distribution, which means the orders are the mean and then median and the mode. For the symmetric ones, and then everything comes to the same in the middle, okay? Yeah, so we'll always get mostly get these three types. All right, that'll be all for the 3.1. Thank you for listening.